Cycling is a great way of commuting. However, most bikes don't show statistics such as the current time or your estimated arrival time, which are really important if you want to ensure you aren't late. And while smartphones technically solve this issue with Google Maps, they're quite bulky, distracting, and look quite awkward on top of a bike. After realizing that commercial devices were either really expensive or ugly, I decided to seek a more elegant solution to this problem, which I'll show you in this video. This video is sponsored by PCBWay. More on them later. To show the statistics, I needed a display. For it to match the build's requirements, the screen needed to be sharp and high resolution, compact so that it would blend in with the bike, and fairly bright so that you could see it in the sun. Since I wanted to display how much time I had left until I got to my destination, the device needed to have access to my exact location while biking. Instead of integrating a separate GPS module into the device that would increase the amount of wiring and cost, I decided to instead use the one I already had in my phone. Using a simple app along with Bluetooth, I should be able to send accurate location data directly from my phone. After looking through various options, including the possibility of getting many separate components and wiring them together, I ended up going for an all-in-one solution, the ESP32T display by LilyGo. This was an easy choice since it ticks all of the boxes. It has a beautiful AMOLED screen, it's compact, has USB-C, and even includes a LiPo charging circuit for the battery. Since it's powered by an ESP32, it's easy to program and already has the integrated Bluetooth that I need. On top of that, the board costs around $40 with shipping, which I think is a pretty good deal considering all of its features. All that was left to do was pair it with a sufficiently sized battery. I went with a 500 mAh one, which should last at least 2 hours when factoring in the power draw of the display. With the hardware figured out, it was time to design the software, which would prove to be the most challenging part. Before working on the main app, I ran some example code to test out the Bluetooth and make sure my phone could connect to the board. Afterwards, I moved on to make the smartphone app that would send information to the ESP32. To do this, I used a framework called Expo that lets you create cross-platform mobile apps using React Native. While I'm by no means a proficient React programmer, I was able to find many helpful resources about using Bluetooth and location, which helped me a lot along the way. After some time, I had a very basic version of the app that could utilize the phone's Bluetooth and location information. After some bug fixes, I had a more refined version of the app that I was pretty happy with. Since the main interface is supposed to be on the display, the app is very simple, as its main purpose is to send data to the screen. This function heavily relies on the free Google Maps API that lets you embed maps, calculate distances, and generate estimated arrival times. Once the app was done, I returned to the display and focused on making the minimal user interface that I wanted on the screen. At first, I tried making the design inside of SquareLine Studio, which is a program that lets you design interfaces for many popular displays without needing to write any code. However, no matter what I did, I couldn't get the generated code to upload to my display. Because of this, I decided to instead manually write a simpler version of the UI. With the help of the TFT ESPI library and its built-in graphics, this turned out to be fairly easy. After some bug fixes, visual improvements, and refinement of the code, I had the completed interface. With both of the apps now finished, it was time to see if they would work together. Once I discovered the device, I paired the display to my phone and chose a location. After pressing the start button, the location data from my phone gets received by the display and the various statistics are updated. This also works with the phone off, meaning that the background functionality was working perfectly. Now that the software was done, I went to build the mounting mechanism to hold the bike screen. Knowing that the screen will eventually need to be taken inside to charge, I began thinking of a quick and seamless way the screen could be detached while also remaining secure. To achieve this, I designed a rail that lets the screen slide into the clamp using just the right amount of friction. After some fine-tuning of the tolerances, it should be tight enough to securely hold the screen. Once I was happy with the design, I 3D printed all of the components, which, if you don't have a 3D printer, then you might want to check out this video's sponsor, PCBWay. Besides offering quality and quick PCB manufacturing services, they also have CNC machining services and 3D printing, with many different color and material options to upgrade the look of your project. You can easily upload your 3D files to their website and customize them to your liking before you place your order. Be sure to check out PCBWay in the link below to learn more. Now that all of the software and 3D printed parts were finally complete, it was time to finish the electronics and combine them together. I started by soldering the battery and power switch. I stripped the wires on the battery and soldered on the new battery connector that came with the display. Afterwards, I fitted in the switch and connected the battery before attaching the lid to cover everything up. To secure the clamp onto the bike, I simply fastened 2 M3 bolts into the heatset inserts until the 2 parts were tight enough. Finally, I finished everything up by sliding the display piece into the rail. To use the device, you need to power it on, open up the app, and pair it through Bluetooth. After they're both connected, the main screen on the app lets you pick your destination by moving around the map marker. After that's chosen, pressing the start button will tell the app to begin relaying your destination and current location to the screen. To fully test it out, I attached the display to my bike and headed outside. Despite trying my best to avoid the bumps on the road, I eventually ended up hitting a few. Thankfully though, they were no problem for the clamp or rail system, and they stayed attached. As you can see, the speed, current time, and battery voltage are displayed along with how many minutes and miles are remaining until you get there. As I got closer to my destination, the remaining miles started to decrease and I was closing in on the ETA. All of this is happening while my phone is turned off and safely in my pocket. Overall, I think this build was a success. All of the functions such as the speed, ETA, and current time get updated on the display from the app and work how I want them to. The clamp is strong enough to withstand bumps in the road, and the device is easy to mount and detach from the bike. On top of this, the phone app is quick and lets you easily pick a different destination. However, this build is not perfect and could be improved with a brighter screen, since this one is just a bit too reflective and is barely visible in direct sunlight. Despite this minor issue though, I think this build is a great addition to my bike and commute, and I'll definitely be using it in the future. If you enjoyed this video, make sure to subscribe and I'll see you in the next one.